are all sorts of strange and unusual things that happen every day. Some people may find these things frightening because they don't understand them. But scientists are different. They find unusual events fascinating and immediately set out to find out how and why they happen. One of the most unusual things in our world is electrostatics. And that's exactly what we'll be investigating in this series of lessons. We will learn how static electricity is generated and how it affects our everyday lives. Hello, my name is Keke Mputi. In today's lesson, we are going to look back in time to find out how scientists discovered that objects become charged with static electricity. And then we'll see how they worked out a way to explain it. By the end of this lesson, you should be able to describe how an object can be charged with static electricity, explain why objects become charged with static electricity, and identify conductors and insulators. The study of electrostatics began hundreds of years ago. The person credited with the discovery of electrostatics was Thales the Milesian. He lived more than 2,500 years ago in the city of Miletus, which is now a part of Turkey, and he also studied in Egypt. Now, Thales was a real revolutionary. You see, in the time that Thales was alive, about 600 BC, all natural events like rain, thunder, and lightning was explained as the actions of the different gods. Thales changed this way of thinking. For example, he proposed that all land on the earth were floating on water, and that whenever the water moved, the land must move too. Using this reason, he tried to explain earthquakes without referring to the actions of the gods. But Thales did not only think up wild ideas, he also carried out experiments to test them. In fact, some people even refer to him as the father of the scientific method. It was while doing one of his experiments that he discovered that certain objects, when they were rubbed with wool or fur, seemed to gain a new property. He also noticed that if he rubbed amber for long enough, a small spark would jump between the amber and the wool that he used to rub it. Nowadays, we say that objects that have this property when they are rubbed become electrically charged. It is interesting to notice that the word electricity comes from this Greek word for amber. Unfortunately, very little scientific progress was made in the field of electricity after Thales made his discovery. And it was only in 1600 that a scientist called Walter Gilbert tried to explain what actually happens to amber when it's rubbed with wool. He called the attraction between rubbed or charged amber and other objects such as hair or bits of paper an electrical attraction. He suggested that there must be an electrical force field around the amber. In 1733, another scientist called C.F. Dufay showed that amber was not the only material that had electrical properties. He showed that when glass was rubbed with silk, the glass also seemed to become electrically charged. However, he noticed that the type of charge that glass stored was different to the type of charge that was stored in amber. Because of these observations, he suggested that there are two types of electrical charges and that these cancelled each other out. By the early 1800s, many scientists were investigating electrical properties. The most famous of these is the American Benjamin Franklin. He did many experiments, including an investigation into the nature of lightning, and he proposed a very interesting theory. He suggested that inside materials there is a fluid that gives objects their electrical properties. When certain objects were rubbed, they would lose this fluid and become negatively charged, like amber. When other objects were rubbed, they would gain this fluid and become positively charged, like glass. Franklin's theories were not totally correct. To really understand what actually happens when objects become charged, we need to have a look at the structure of an atom. This is a simple model of the atom. The central area or nucleus of the atom contains subatomic particles called protons and neutrons. Protons are positively charged and neutrons are not charged at all. Electrons take up the rest of the atom's space. These subatomic particles move around the nucleus and are negatively charged. An atom is electrically neutral, which means that it has no overall charge. The number of positive charges and the number of negative charges in an atom are the same because the number of protons equals the number of electrons. But if all atoms are neutral, how do objects become electrically charged? Well, electrons are found towards the outside of the atom. They can move away from the atom and leave the atom with more positively charged protons than negatively charged electrons. This is what happens when an object is rubbed. Objects that lose electrons become positively charged because they have more positively charged protons in their atom than negatively charged electrons. Objects that gain electrons become negatively charged because they have more negatively charged electrons than positively charged protons. An object like this glass rod is made up of neutral atoms and so will be electrically neutral. When the neutral glass rod is rubbed with a silk cloth, electrons are rubbed off the glass rod and onto the silk cloth. The glass rod will now have fewer negatively charged electrons than positively charged protons. The overall charge on the glass rod will therefore be positive. Now try and work out what happens to amber when it is rubbed with wool. Remember, the amber becomes negatively charged. That's it. The atoms making up the amber have electrons rubbed onto them from the wool, so the amber will become negatively charged. The atoms will have more electrons than protons. What you should always remember is that while all this is happening, the overall number of electrons does not change. The electrons have just changed their position. We know this because one of the laws of physics, called the law of conservation of charge, states that the number of positively and negatively charged particles is equal and remains constant. Now, the next question I want us to investigate is whether or not all objects become charged when they're rubbed. You can do a very simple experiment to try and solve this problem yourselves. Rub a glass rod with a piece of silk and hold it next to some small pieces of paper. What do you observe? Repeat the experiment by rubbing a plastic ruler on a shirt and holding it next to a small piece of paper. Write down your observations again. Now rub a metal rod with a piece of cloth and hold it next to small pieces of paper. Are your results different from when you rubbed the plastic and the glass rod? Why don't you discuss your observations with some classmates? We found that the glass rod and the plastic ruler become charged when they are rubbed because we observed how they attract small pieces of paper. The metal rod does not become charged when rubbed. Irrespective of the kind of cloth we use, we know this because it doesn't attract the small pieces of paper. Can you explain these observations? Why does the metal not become charged? Now, to answer this question, you would have to think about what you know about the properties of metal. You should recall that metals are good conductors of electricity. This means that electrical charges can travel through them. Negatively charged electrons can travel through metals as an electric current when metals are connected into an electric circuit. Plastic and glass are insulators and do not conduct electricity. This means that electrical charges can't travel through them but remain stationary or static. When a metal rod is rubbed, charges that are transferred can move through the metal rod. The charges move through the rod in order to keep the number of positive and negative charges in the rod in balance. The Earth is a source of negatively charged electrons, and these may flow between the Earth and the metal rod through your body to ensure that the metal rod remains electrically neutral. So the only way to charge a metal rod is to keep it isolated. In other words, not in contact with any path to the Earth. When an insulator such as a glass rod or a plastic ruler is rubbed, the charges remain stationary. They cannot move through the insulator, and so there is no movement of charge between the insulator and Earth. Okay, let's recap what we've learned so far. Insulators become charged when they are rubbed. Some insulators become negatively charged when electrons are transferred onto the object. Other insulators become positively charged when electrons are transferred off them. The charges on the insulators remain in a fixed position on the surface of the insulator. We say the charges are stationary or static, not able to move. That's why this type of electricity is called static electricity or electrostatics. Metals are conductors of electric charge. They are not able to hold a charge on their surface unless isolated. When charge flows through a metal conductor, we call this type of electricity current electricity. On that note, here's your task for today. Draw a sequence of diagrams to show how a piece of amber becomes negatively charged when rubbed with some wool. Be sure to join us on our next lesson in this exciting series on electrostatics. See you then!